Hello and welcome. We're going to go over this problem today, merge sorted array with the UMPIRE process. And so the problem description is you are given two integer arrays num1 and num2 sorted in non-decreasing order and two integers m and n representing the number of elements in nums1 and nums2 respectively. Merge nums1 and nums2 into a single array sorted in non-decreasing order. Final sorted array should not be returned by the function, but instead sorted is stored in the array nums1. To accommodate this, nums1 has a length of m plus n, where the first m elements denote the elements that should be merged and the last n elements are set to 0 and should be ignored. Nums2 has a length n. Okay, so now we want to go about understanding this problem. So what we have is an inputs of array 1, array 2, and m and n. So integer arrays, array 1, integer arrays, and m and size of array 1, 2. Okay, so the outputs is merged array of array and array 1. And I should say the eminence size of non-empty. So array 1 is padded with zeros at the end to fit array 2 inside of array 1. So merged array, so the output is a merged array in array 1, um, sorted in non-decreasing order. So, so let's take a look at examples here. So example 1 is the array nums1, which is 1, 2, 3, and padded with 3 zeros at the end, because that's the size of nums2, which is 2, 5, 6. So the size of nums1 with the non-padded zeros at the end is m3, m equals 3, and the size of nums2 is n equals 3 as well. And so to merge the array, we just check to see how the second array fits into the first array. So the second array 2, so 1 is less than 2, so it's not going to be before, 2 is not going to be before 1. And then we go to the next number, and nums 1, and it's 2, and 2 compared to 2 is equal to 2, so we can insert that into before 2, so we have 1, 2, 2. And then then we go up to the number 5, and we compare that to 2, and 2 is less than, so we go up 1. Nums 1, we go to 3, and that's less than 5, so we go up another one, and we see the space, and then we put 5 in that space because it's an empty space after 3, so we have 5 there, and then we increase the nums2 index by 1, and then we have 6, and we so far we have 1, 2, 2, 3, 5, and then we compare the index 5 with 6, and see that 5 is less than, so we go to the next index, and it's a 0, so we're going to put 6 there, and then we can uh, uh, pop the 0 elements off the end, so that we have the array or the output 1, 2, 2, 3, 5, 6. Okay, so in example 2, we have nums1 equals 1, so there's only one element, nums2 is empty, so that's n 0. So the output is just going to be the one element array. So we're merging 1 in the empty array. And so the third example is nums1 equals 0, and m equals 0, and nums2 equals 1, and n equals 1, so we just have the outputs 1, where we merge nums1 or nums2 into nums1, and it's pattern equivalent 1, 0, so we just insert 1 to that 0 place in nums1. So the arrays we are merging is the empty set and or the empty array and 1. So the result of the merge is 1. Okay, so now that we have an understanding of this problem, now we can match this problem to a similar problem. So similar problems include array manipulation and sorting. Okay, and so now let's plan for this problem. So what we want to do is we want to uh, put array 2 into array 1, and then we want to sort array 1, and then we carry over the elements. Carry over the elements of the sort to array 1. So let's go about implementing this process. So the implementation is going to be for I in range n plus n. I'm going to set array 1 I to array I minus m. Array 2, or maybe I should say nums 1 equals nums 2 I minus m, index I minus m. And then we want to sort nums 1, and then for I in range n plus m. Array. So that's going to do it. So we have an accepted solution. And we have an accepted solution. So that's the solution to this problem, merge sorted arrays. So now let's step through the review of this process. Okay, so we're going to print merge. This input is 1 2 3 0 0 0 3 and 2 4 5 3. So we're going to first go in and we're going to set nums1 to be appending these values of nums2. So we just set the zeros at the end to the elements in nums2, and then we sort the array. We get the sorted array, and then we put the sorted array into nums1. And then we finish and we get 1 2 2 3 4 5, and that's it. That's the merge sorted array. Okay, so now we can evaluate this problem. So in evaluation of this problem, we have O in space complexity because we have to use the sorted array to uh, store the elements of the sorted array of nums1. And this is n log n time complexity because we use the sort function to sort this array. And that's just plus this additional ON, which is not much, which means that the sorted um, part is larger, so we have ON log n time complexity. Okay, so now that we understand this problem and have an analysis of this entire problem, we can end here. Thanks for watching.